Yes, sir.
Okay, let me share the screen. Yes, screen is visible.
Yes, sir.
Yes, sir.
Okay, okay, and voice is also perfect. Okay, right?
Yes,
Yes.
sir.
Oh, thank you. Yeah. So the last discussion, today we will try to close soon. Okay, I'm not feeling well. Okay, like last discussion we were trying to address the method of Lagrange for solving a type of, you can say, quasi-linear PD, first order quasi-linear PDs. So so we have the form of like this capital P function of x comma y comma z, small p plus q of x comma y comma z time q is equals to r. And I hope you understand what is this bracket in x comma y comma z means. Is they are function of, could be possibly functions of x comma y comma and z variables. So when this is the possibility of the first order partial differential equation, then we say that this is a quasi-linear PD, and the Lagrange equation is dx by capital P is equals to dy divided by q is equals to dz by r. So it's very simple to memorize as well. Dx, okay, means total derivative with respect to x, and capital P is the coefficient of dou z by dou x. Dy divided by q, okay, and which is a coefficient of dou z by dou y. And the rest dz by r is the right hand side. You have to shift everything on the right side, and it is very easy to compare, and you can put them in the following equation, which is known as Lagrange's equation. Okay. Sometimes it is also known as auxiliary equation. Okay. Then what we have done in that method is you take two families, okay, which solve this system. Okay. So there are various ways. That is not a unique way. Okay, so you can choose, somebody can choose dx by p equals to dy by q, or somebody can choose dx by p equals to dz by r, or you can also choose the second and third, dy by q equal to dz by r. Further, not only that, you can also choose the linear combination of them. So x dx divide means you can also choose that like x dx plus let's say y square dy. That is also ratio is equals to x times p plus y square q. Okay, so such type of the family of solutions. So two family of solutions are necessary. One family of solution you can call u of x comma y comma z equals to a, and another family of solution is, let's say, v of x comma y comma z equals to b. Suppose you are successfully find out, means once, and another thing is you have to know, you have to be careful that these two families should be linearly independent. And I hope you can always determine between two families whether they are linearly independent or not. Means in the same sense like two vectors are linearly independent if or you can say linearly dependent if one of them is scalar multiple of the other. So if you are able to see that U and V are similar families, same families, okay, and they are linearly dependent, otherwise linearly independent. So it's very easy to find out that thing. Then once you have these two families, then the solution, the general solution, what we write is this is it's an arbitrary function of f of u comma v is equals to, or there are various ways to write this general solution. You can also write u equals to some general function of v. Okay, so this will say a general solution for the given first order quasi-linear PDE by using the method of Lagrange. Okay, now last time we have so we have the following associated Lagrange's equation. Divided by this, dz divided by this. So we have the following. Okay, so then we have choose the last. And we can see easily that last two pairs will allow us to find out at least one family. It's very simple to observe because this factor will get cancelled and you have dy by y equals both sides and add constant of integration and so on, and you will be able to identify one of the family. Okay, right. So one family was easy. Okay, that we have found u equals to this. So for another family, we have tried sublinear combinations like we have also seen that y dx minus x dy, y time multiply dx and x time dy, and taken the difference. Okay, so that something will get cancelled, but what we observe is they are not landing onto the simple situation. Okay, so what else we can do is we can also target here that there's the factor target this. Okay, whether it is possible to get here any linear combination with dy, this dz, so that you will have this factor in this form somehow, and suppose then it will be simple out. Okay, so that's an idea. So to get that, so you have you can multiply this by you have okay, so let's multiply so you can further find out. So because it's here is x times z. Okay, so you have this is C. You have this linear combination z minus y square minus 2x cube. Okay, in the both terms, right? What you want is z minus 2y square. So what you can do, you can take the difference z and you can multiply it by 2y and take the difference. This will become out. You will remain only with z minus 2y square, right? Yes. So 2y dy minus z dz, or I can say minus 2y dy plus z dz. That will be turn out to be you have this is going to be no, there is no need of multiply here by z, right? Okay, so you have z minus 2y square we require, right? Yeah, so it's not need here z. So what you observe is this is divided by z minus 2y square time. You have this is z minus y square minus 2y minus 2x cube. Now this is equals to 2y. Now this will get cancelled. Okay. Now what if you cross multiply, whether we are able to write in the, you can say, exact differential equation concept, okay, whether we are able to do that. Okay, so you have, what you have is here is this is going to be minus 2 by y plus dz is equals to z minus y square minus 2x cube divided by x dx. Okay, so let's simply find out. This is going to be minus plus x dz is equals to z dx minus y square dx minus 2x cube dx. Now let's push everything on the right side or on the left side, either ways. So what you will have is going to be minus 2xy dy plus x dz minus z dx, okay, plus y square dx and plus 2x cube dx is equals to 0. Now you can look at everything individually. Okay, what you can look at is this is easily integrable, right? So the last term is easily integrable. But here you have some x dy here, x dz, z dx, and so on. And here is 5. But these terms are not integrable, means like in a straightforward manner. So you have to do some adjustment here. Okay, so how to do that? Now let's concentrate on this x dz minus z dx. Okay, so see, it is not, it is going to be d of z by x time x square, x dz minus z dx. So this term is nothing but x square time total derivative of d of dz by x. Okay, now the next term, this is going to be y square dx minus 2xy dy. Okay, so it is again x square time d of y is minus first, right? It's going to be minus plus 2x cube. Now this x square can be adjusted. Now you can divide. Okay, so that will be giving you d of y square by x plus 2x dx is equals to 0. Now it is easy to integrate. Now this integration, both sides, what we will get is z by x minus y square by x plus x that I will call as v. So the general solution p, the general solution will be f of u comma v equals to 0. This implies f of y by z comma This is the final general solution for this. So far, we have not done any initial value problem. Maybe next we will do that. So as I told you, there are multiple ways, possibly multiple ways to handle this type of problems. Means you are supposed to identify two family of solution by looking at any other way linear combination. So this is the one way what we have just now observed. If you have any question, you can ask. Yes.
In the previous slide, means x and y are independent variable.
Yes.
So minus 2xy dy is integrable, means x will come out of integration.
No, see, whenever you are dealing with partial differential equation, the situation will be different. Here you are dealing with a situation where total derivatives are involved, d by dx. Okay. So here you should observe this equation in my like x, y, and z all are a type of independent variables, type of, okay, it's not they are actually, okay, but here you have to make your understanding that they are, you have to do independent, you have to do this perform integration independently. Did you get my point?
Yes, sir, but we have assumed like
Huh.
that only. That is dependent on x and y. And x and y are independent. I think so.
Okay, what is your doubt here then?
Sir, means if x and y are independent, then x, y, dy is integrable. X will come out of integration.
No, 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 no. Again, when you are integrating, see, suppose I put okay, x into y dy. Okay, you say that x and y are independent, they will come out.
X will come out
This
because
This is what you are saying.
yes, sir, because it is with respect to y.
Huh. See, the situation is, say, if instead of this dy, suppose I have this is dou y, a partial integration with respect to y. So this is a total integration with respect to y, and this is a partial integration with respect to y. So when you are integrating partially with respect to y, that the situation is okay. But it is not partial integration here, it is a total integration. Okay. So when you have here, suppose again, if you have here is this partial integration with respect to z, dou z, then it's fine. You can integrate. Get my point?
Yes, sir.
You get the difference here. Dy is d is denoting with what? Total differential. Okay, and dou is this notation will denote for partial integration. Okay, so whenever you are performing the integration, you have to keep in mind that here is dy or dou y. So if it is dy, you can't do that. If it is dou y, you are means you are allowed to do that. Not a problem. Is that clear?
Okay, sir.
Okay. Any other doubt? Okay. So let's go further now. So let's see the next problem. If you write it in the form, So it is x minus 1 whole square plus y square equals to 1. Unit circle centered at the point 1 comma 0. Okay. So the integral surface of the, you have to find the equation of the integral surface of the differential equation which passes through the following circles. So you know what is the parametric equation of this circle is x equals to 1 plus cos t, y equals to sin t, and this is z is 0, so z is 0. It's not. Okay, on that xy plane, z is 0. And t is running from, you have 0 less than equals to t less than equals to 2. Comma 0. Okay. Now this will come later once we found the solution for this. Okay. So let's find out the solution. Okay. So if you, I'm writing here, so associated dy divided by equals to dz. So let's look at here. So dx divided by the small p coefficient, that's 2y times z minus 3. The q coefficient, that is 2x minus z. Dz divided by y times 2x minus 3. Okay. Now, I'm leaving all of you on you that which pair you should choose. Okay, some of you must suggest here. Okay, we wish to solve this problem means we are supposed to identify two parameters, not two parameters, two families of solution u of x comma y comma z equals to a and v of x comma y comma z equals to a. So which pair you wish to start with, or which linear combination you wish to start with? You can have pen and paper with you, okay? And you can try and you can let me know. Our goal is to identify two solutions. I hope my question is very clear to you. Okay? If my question is not clear, you just let me know. First and last equation. Chitra?
Audible.
Chetri? Yes, yes, you are audible.
We
Okay.
can solve first, I mean dx by 2y into z minus 3 and dz by y into 2x minus 3.
How means like I just want to know. Okay, so you means that once you use this dx and dz, that y will be cancelled out and it will be only ODE in terms of x and z. That's what?
Yes,
That's good. So once you have this, let's say dx divided by 2y times z minus 3 is equals to dz divided by y times 2 get cancelled out. So you are only remaining with this thing, and it's very easy, right? This is going to be 2x minus the cross multiplication dx minus 2 dz is equals to 0. So it's very easy to integrate now. So this implies on integrating both sides, what you will get is x square minus 3x minus 2z is equals to. Right? So the one family,
It would be
sorry, a
2
constant.
times z minus.
Huh? Oh, okay. 2
Instead
times
of
z
this
minus
2, yes.
2 times z minus 3. Okay, thank you. To the space problem. Okay, so let me go to the next page. So what you will have is 2x minus 3 dx minus 2 times z minus 3 dz is equals to 0. So this implies, so if you integrate both sides, what you will have is x square minus 3x minus 2z dz is minus z square plus 2 into 3 is 6, right? 6z is equals to 8. So this will give you u of x comma y comma z is equals to x square minus 3x minus z square plus 6z is equals to 8. So you have got one family of solution. So can anyone suggest another family of solution now? Yes, right. Yes. Can we do something with the last two pairs? I'm getting that intuition, but whether you are able to get it or not. Okay. See here, dy and dz are
with
there.
y
Yes, pardon?
subtract, multiplying with y and subtracting like y dy minus.
Yes. Okay, because then what will happen is, because in the denominator you have 2x, 2xy, and here is already 2xy. So if you subtract, these two terms will get cancelled, only yz terms will be remaining. You can use dy plus dz. So if you try it and also y dy minus dz divide by, so y into 2x minus z minus you had y into 2x minus 3, right? That was there. Yes. Okay. So this is equals to y dy minus dz divide by, so 2xy will get cancelled. So you have, right, plus 3y. Okay. Now, this is equals to y dy minus dz divide by y into z minus 3. Okay. Now, what is dx? So dx is dx divided by 2y times z minus 3. So this must be equals to dx divided by 2y times z minus 3. So z minus 3 will get cancelled. Y will also get cancelled. And these both two pairs you can solve. This implies you have 2y dy minus 2 dz minus dx equals to 0. And if you integrate both sides, you have y square minus 2z minus x equals to sum d. Okay, so this will give you another family v of x comma y comma z is equals to y square minus 2z minus x equals to b. So the general solution, therefore, general solution will be f of u comma v equals to 0, means f of v is y square minus minus 2z minus x, and what is u is x square minus 3x minus z square. Is equals to 0. So this is the general integral surface, but we are only focused on this is the initial value problem. Okay, z equals to 0, and you have this is x square plus y square equals to 3x. So passes through this value, so 2x, which is nothing but x minus 1 whole square plus y square equals to 1. And we already have the parametric equation with x equals to 1 plus cos t, y equals to sin t, and z equals to 0. Now, you have two families, u of x comma y comma z equals to a, and v of x comma y comma z equals to a. How to satisfy the equation? Okay, they will also going to be the solution. Okay, so they also must pass through this circle. Okay, similarly, you will try to get a relation between these constants a and b. Okay, your job is to eliminate them. Now you have all the both the things now. What is u of x comma y comma z is u of x comma y comma z is equals to, you have x square minus 3x minus, okay, so x square minus 3x minus 6z is equals to a, and the v of x comma y comma z is equals to y square minus 2z minus x is equals to b. Now, they both will pass through that circle. So means you have to substitute x equals to 1 plus cos t, y equals to 1, y equals to sin t, and z equals to 0. Cos t whole square minus 3 times cos t, cos t, 3 times 1 plus cos t is equals to a. So solve this. What it will give you is 1 plus cos square t plus 2 cos t minus 3 cos t, so minus cos t. Minus 3 is equal minus cos t minus 2 is equals to a. Now the second equation, what it will give you is, so v of x comma y comma z is equals to y square minus 2 z minus x equals to b. That will give you sin square t minus, this is 0, z is 0, minus 1 plus cos t is equal to b. Now sin square t, because you are supposed to identify the relation between a and b. Okay, so what you can get is, here is sin square t, you can replace it by 1 minus cos square t. Okay, so 1 minus cos square t minus 1 plus cos t is equals to b. So this will give you, one will get cancelled. What you will get is minus cos square t minus cos t equals to b. And what we have previously, cos square t minus cos t minus 2. Cos square t minus cos t minus 2 is equal. Okay, let's see, sin square t. So you have, this is going to be cos square t minus cos t. Have to eliminate them. Cos t equals to 1 minus a minus b. But no, that's okay. But can we, because we have to get the pure relation between a and b.
Then we can substitute this value in one of the equation, and then we can get relation between A and B.
Okay. So let me check first that whether we have done all the things rightly or not. Let's first, because that will again lead to a very like some work equation. This is So you have this first two pairs. Let's verify that. So this is going to be 2, 8, 8 a minute. Okay. I will get cancelled. 2x minus 3 dx. And it's equal to 2 times z minus 3 dz. That's fine. X square minus 3x minus 2z plus 6, right? So minus z square plus 6z is equals to 8. That's fine, perfectly fine. Now another relation, y dy minus dz divided by y into 2x minus z, okay, and minus dz is by 2 plus xy minus plus 3y.
Sir, your voice is breaking.
My voice is coming. Am I audible?
Yes, sir. Not audible. But sir, it's breaking.
Okay. Now it's fine, right?
Yes, sir. Now it's fine.
Okay. So now look at here. So I think we have, may say y times 3 minus z here. So it is must be here. There's a minus sign. Okay. Minus 2y dy plus 2 dz minus dx minus y square plus 2z minus x. So minus y square plus 2z minus x equals to b. So your family is v. Family is here minus y square plus 2z minus y square plus 2z minus x is equals to b. Right? Now, it's fine, right? YD now. It's equals to 0. Now this is fine. Okay. Now, here minus x. So here is minus plus. Okay. Right. So here is minus y square plus. So here is minus. Okay. So we have done a mistake here. So let's correct it first. So what you get is a minus 1 minus cos square t minus 1 minus cos t is equals to b. Now you have, this is going to be cos square t minus cos t minus 2 equals to b, means the relation is a equals to b. This implies u equals to v. Okay? So this will give you u equals to v, means what is u is x square minus 3x minus z square minus z square plus 6z minus y square plus 2z minus. This implies we have x square plus y square x, right? Minus 3x plus x is minus 2x plus 4z is equals to 0. So this is the integral surface which will pass through. This will be the integral surface which will pass through the given initial curve. Okay, that is unit circle. So do you have any question? See, most of the time, many time in generally, you will get a very simple relation between A and B. Okay, if you're not able to relate them is by passing through curve, means you just go and check, okay, your solution first. Then only you will lead to the next level. Okay, that's a generally this is the trend. Okay, you will get a very simple relation. Okay, right. So this is the method of Lagrange. So let's deal with some very special type of first order PDEs which may be non-linear. Okay, which may be non-linear. Okay, special type means if they are of specific form, then how to solve? In the general, the equation of first order PDEs involve x, y, z, p, and q equal to 0. Maybe non-linear, it may be quasi-linear, it may be any. But only of first order PDE, means only highest order derivatives are of first order. Now, suppose, so first type you can say type 1 is, suppose in the equation you don't see explicitly any of this variable. Okay, x, y, and z. Means like suppose you have the form is like p plus q equals to 0. Or some means yeah, that's fine. Or suppose you have p into q equals to 0. Or suppose you have square root of p plus square root of q equals to 0. It's a non-linear. It's also non-linear, but the previous one was linear. This first one was linear. Maybe you have some like p square plus q square equals to 0. Only involving p and q. You know very well about which notations p and q. So in that case, the Herbert notation will be of the form z equals ax plus by plus c. Means how one can suggest that this is going to be the possible solution. Okay, see, there are 3 arbitrary constants. Okay, but the general solution will have 2 arbitrary constants. Okay, that you should keep in mind. So from here, this equation, what we can look at is, this is what is P. From here, this implies P is equals to A and Q equals to B. So if you replace P equals to A and Q equals to B, you will get the relation between A and B. Either B as a function of A or A as a function of B. Either way is fine. So this B is either you replace this B by function of A or you replace A by function of B, means you are remaining with a 2 arbitrary constants. So you can treat this as a general solution. Okay, so 1 arbitrary constant can be eliminated in this fashion. So whenever you see such type of equations, okay, these type of equations where you only involve P and Q, you can directly attempt with the solution z equals to ax plus by plus c, where a and b are related by this relation that you can, in general, f of a comma b equals to 0. Means you replace p by a and q by b and find out. So we can solve these three, okay, one by one. So let's take this one, p plus q equals to 0. So it's a type 1, I can say that means it's only involved p and q. There is no explicit involvement of x, y, and z. So the general solution will be of z equals to ax plus by plus c equals to 0. So this will give you q equals to b. Okay, and so therefore this implies, so this you can say 1. So 1 implies, equation 1 implies a plus b equals to 0. This implies either b equals to minus a or a equals to minus b. So this implies z equals to a time x minus a time y plus c. This equals to a time x minus y plus c. So this is the associated family for which this is the solution. Okay. Now let's take a second equation, that is p into q equals to 0. Or let's take, instead of 0, let's take 1 constant. Now this is the involvement of p and q only. Constant can be treated as any function, right? So this explicitly involving only variables p and q, not x, y, z. So the general solution will be z equals to ax plus by plus c. This will give you p equals to a, q equals to b. Now this you can call as 1. So therefore 1 implies a into b equals to 1. This implies b equals to 1 by a. So this will give you z equals to ax plus y by a plus c. Now, similarly, you can go with the third equation. So let's take this is square root of p plus square root of q equals to 1. Now, again, this involves only p and q. So general solution will be z equals to ax plus by plus c. This will give you p equals to a, q equals to b, and 1 implies square root of a plus square root of b is equals to 1. You can call 1. So from here, square root of b is equals to 1 minus square root of a. This will give you b equals to 1 minus square root of a whole square. Now you can substitute here. So then the solution will be square y plus c. Okay. Now let's deal with type 2, another type. Okay, so I have already dealt with this, some of the problems. Let's go with this. So the another type is the following. This is somewhere known as, is also known as Clairaut's form. We have also seen this Clairaut's form in the first order differential equations, like if you recall, that's y dash was equals to a somewhere like this was Clairaut's form in the ordinary differential equation was y dash a not y dash, it's the this was x time somewhere something like that only, x time y dash plus some similarly function of y dash, or I mean it's like some function of, I'm not actually, let's I will let you know in the next class. Okay, so this is called the Clair's form in the first order PDEs, where you can write that z means the equation in the following form, which involving x, y, and z. Okay, so z equals to px plus qy plus phi of p comma q. So now what you can look at is here for the solution of this, what you can have is x equals to, not x equals to, you can substitute p equals to a and q equals to b, the constant. Okay, so once you substitute, so if once you know this is a Clair's form, the general solution can be obtained by replacing p equals to a and q equals to b. Okay, so the general solution will be z equals to ax plus by plus phi of e comma b. So, but it is always a challengeable. Okay, so there are various type of PDEs which can be actually reduced to this form. Okay, by using some transformation techniques. Okay, so these are very simple to target. When you have in this form, the solution will be in this form. Okay, so this means for if you are verified that the given first order PDE is in Clair's form, you can obtain a general solution by just replacing p equals to a and q equals to b. Okay, right? So where a and b are arbitrary constants. So again, so only two arbitrary constants are allowed in the general solution. Because they are in Clair's form, straightforward, because you can verify z equals to px plus qy plus function of p comma q. Similarly, the second equation z equals to px plus qy plus some function of p comma q plus by plus a time b, and here is ax plus by minus 2 square root of a. The general solution will be this. Z equals to. Because your aim is to obtain a family which is associated with this given PDE. So there may be multiple families. Okay, right. Because we have seen already, right? Okay, so another special type p comma q equals to 0. Okay, suppose you don't have the presence of these two variables explicit, then we use a transformation which will reduce it into first order ODE, ordinary differential equation, which can be solved by available methods. Okay, how to do that? You can say let z equals to some function of u, where u is this transformation x plus a1. A is some arbitrary constant. So because here carry forward one arbitrary constant, because one arbitrary constant will come out from the, when you have ordinary differential equation, first order differential equation, the solution will lead to the one arbitrary constant. So 1 and 1, 2. Now, how this help you, this transformation is, see, it's implicitly is a function of x and y. Now, from here, what is P? This implies, what is P? P is dou z by dou x. But z is function of u and u is a function of xy. So, dz by du time dou u by dou x. Chain rule. So, that's going to be dou u by dou x from here, what? So, that's going to be dz by du. Now, and q is equals to dou z by dou y. That is equals to what? Dz by du time dou u by dou y. So dou u by dou y from here is a time dz by du. So you replace p by dz by du, q by a time dz by du in the original equation, and you will get a first order ordinary differential equation. Okay? Then you can solve this type of PD by using any available method of first order differential equation. So let's do one or two problems based on this. So let's do solve this problem. P into 1 plus q equals to qz. So P into 1 plus q is equals to qz. So this is of the form f of z comma p comma q equals to 0. So I'm going to use the transformation z equals to p of u is equals to x plus ay. So just now we have derived, okay, what is p is dz by du. Q is, you can also again derive this, okay, a time dz by du. So you can say this is what? So 1 implies dz by du into 1 plus a time dz by du is equals to a times z dz by du. So this dz by du get cancelled. And this will implies 1 plus a time dz by du z minus 1. Now you can use variable separable. A time dz by a times z minus 1 is equals to du. Now this implies, so integration of this is nothing but ln of a times z minus 1 is equals to u plus some b coefficient ln b I can write. So this will give you az minus 1 time b, right, or divide by b, ln m minus ln n is equals to e to the power u a times z minus 1 is equals to b time e to the power u. So that's equals to b time e to the power x plus a by. So you can also solve this. Z equals to 1 plus b time e to the power this a and a arbitrary constant, at least that should not be 0. If it's arbitrary constant, it never be 0. If you have any question, okay. So this is a type 3. Type 4 is as follows. So suppose you have, this is the form given. Okay. There is no Z explicit. There is no Z explicitly. Okay. There is no Z explicitly. Now suppose you are able to write, this implies you are able to separate in some fashion. Means one side is purely is a function of x and p, and you can write, and the another side is a function of y and q. Suppose you are able to do this separation. Is left hand side is function of x and p, and right hand side is function of y and q only. Means either way, okay. Then what you can do is you can substitute that is equals to a. Now what you can do, solve f1 of x comma p is equals to a to get some p is equals to some function of a and x. Okay, you can do that. That is a function of x and p, and you are putting equal to a constant. You can always do that. Okay. Equals to a to get q is equals to g2 of a comma y. Okay, so if you have this, x comma, suppose you are able to write in the following form. Let f1 of x comma p equals to f2 of y comma q equals to a. Solve these two and solve these two for getting p equals to function of x and a, and q is equals to function of y and a. Now note that z is a function of xy. So this will imply the total derivative dz is going to be dou z by dou x dx plus dou z by dou y dy. So that's equals to p dx plus q dy. Now note that if you use this here, p equals to function of x and a, and q is a function of y and a. So you can easily integrate both sides. Okay, so integrate both sides to get the family. That's it. Okay, so substitute, obtain p and q in the following relation, then can be solved by integrating both sides. So you can note down these problems, these two problems, and try to solve by this. Okay, it is very simple. It's already in the form, separation form. First one is the separation form. as q square. Solve these two equations by using this available method and find out the general solution. Okay, thank you. If you have any question, you can ask.
Course project will be a group project, right?
No, it's
Or
individual.
individual project.
Yes, it's individual. Then you can then you could have worked out group wise. Maybe next semester we will figure out. And I have done this with this numerical method course. People have come up with the very, very nice applications. They have beautifully designed the problems. Group project will definitely work well. Okay, but these 2 semesters are you can understand that means like it's a training period. Okay, so where you can learn what kind of problems or what type of the standard what type of standard problems you can look for. Okay? This is an individual project you have to do. Any other question? Okay, thank you.
Thank you, sir.
Thank you, sir.